out of the system. So you want to minimize that drain, the size of the drain. What's the drain? The drain is due to carriers that would be in their excited states, that want to move in the solid and get to that external circuit, getting lost on their way. There are many ways they can get lost. They could decide to go the wrong way. There's some probability that they will go up over this thermal barrier, given by the height of that barrier and the Boltzmann constant. They could decide along the way that they could go down and recombine anyway. They could get here, and when they go this way with holes coming the other way, it's like two crossing trains. There's some probability that when they go to the intersection, the electron will find the hole and then they'll recombine. Sometimes they emit light. That's good if you're trying to make a light-emitting diode. It's bad if you're trying to make a solar cell. Okay? They're actually the inverse process, right? One, you put in voltage and get a light out. The other, you put in light and you get voltage out. So good LEDs are bad solar cells. Good solar cells are bad LEDs. Same physics. Okay, what's the fundamental properties of this loss mechanism? What happens is when you build up electrons, that you're adding dye and you're building up electrons in this material, it's going to try to oppose that. And you can see that happening because as you add more electrons, then it's naturally, because this material was positively charged, as you add more electrons to the material, it's going to neutralize some of that positive charge. That's going to reduce the barrier that we built up in the first place. And so it's going to make it easier for electrons to go up and over the barrier the wrong way. The other way you can make it easier to make them go up the barrier the wrong way is you could decide you wanted to actually add a bias with a battery, or you could have a resistor in there that draws a load. And that's what we want to do with a real solar cell. We want it to do work for us. The more work we demand, the less carriers will be able to give us that work. We're asking to filter their energies by the amount of work we demand. When we only demand a little bit of work, a lot of carriers are capable of doing that. When we demand a lot of work, only a few of them are capable of doing that. In fact, you can see that if we raise this voltage up and up and up, the amount of carriers that can go the wrong way will increase exponentially by the Boltzmann equation. Okay? And that means that instead of going this way, they are flowing the wrong way over the not very good dam that we have built. And the wrong way current is going exponentially with the voltage. Just from the Boltzmann equation.